All right, let's look at number 13 in section 7.1. This one is quite challenging in some ways. We're going to evaluate using integration by parts, substitution, or both if necessary. So you've got to determine which way you're going to go with this. Well, my first thought was to do substitution. I believe that's the easiest way to proceed on this problem. But I'm also going to show you how you can do it with integration by parts. So you can do each one independently, and we'll talk about the result we get. Um, so substitution, I've got in the denominator the square root of 7x plus 1. So that 7x plus 1 is under the radical. I'm going to choose that for my u. Okay, it's sort of the inner function. And the derivative is, of course, just 7. So du is 7 dx. But you see I've got a 7x dx. So I've got 1 over the square root of u. 7 dx is du, but I've got this extra x. How do I handle that? Well, remember, if I can solve for x in terms of u with this equation, then I can replace that x with that expression. So that's what I've done. I've subtracted 1. So 7x is u minus 1. And then dividing by 7, I can solve for x, or multiplying by 1/7. So again, I'm just going to rewrite the numerator here to emphasize x and then bring the 7 dx together, excuse me, over the square root of 7x plus 1. So the x, what's x? That's this, 1/7 the quantity u minus 1. What's 7 dx? That's the du. What's the square root of 7x plus 1? Since u is 7x plus 1, it's the square root of u. Now let's clean this up. The 1/7 can come out, constant multiple, and the square root of u is u to the 1/2. So how do I find the antiderivative of this? Well, split this up into two fractions, right? I've got u divided by u to the 1/2 minus 1 over u to the 1/2. Simplify those. So I'll have here 1 minus a half is a half. That's a plus sign there. Sorry, I messed up. That's positive 1/2. And then the reciprocal of u to the 1/2 is u to the negative 1/2 here. So now notice we can just do these with the power rule. So the antiderivative of u to the 1/2 is 2/3 u to the 3/2. Antiderivative of u to the negative 1/2, adding 1 to a negative 1/2 gives me 1/2 divided by a half, or multiplying by 2. So there's my antiderivative. Don't forget the 1/7 there. Distribute the 1/7 through, I get 7 times 3, 21. Replace u with, remember u was 7x plus 1, minus 1/7 times 2, and then u is 7x plus 1 again. So here is the result. Okay. Now, I'm going to show you this problem with integration by parts. I prefer, I think, the substitution here for me. It works pretty good. Okay. But it's not the only way that could be used. So the same integral I'm going to do with integration by parts. And the way I'm going to do this, I'm going to choose u to be the 7x, algebraic part up top. So the derivative, of course, of 7x is 7, so du is 7 dx. And then everything else is the dv, the dx over 7x plus 1 to the 1/2. And so now I just need to integrate. So I'm very much integrating uh, very much. I'm integrating this function, which is going to be done with a little substitution. So u is 7x plus 1. We get our du. So 1/7 du is dx. And I get 1/7 integral u to the negative 1/2, antiderivative, multiply by the 1/7, and then replace u with 7x plus 1. So this integral is this. And so that's my v. This all the way down here, that's my v. So the u, remember the integration by parts is uv minus integral v du. Okay, and this is the integral u dv in this case. So u is 7x times v, that was the thing we found down here, minus v again, integral, that is v, and then du, right, is 7 dx. So we'll clean this up. Notice 7 divided by 7 just gives me 2x there, times that. And then here I'll notice 2/7 times 7 gives me 2. Pull that 2 out, and I'm just left with the integral of 7x plus 1 to the positive 1/2. Well, this is similar to the way we did this one with a simple substitution. We get the du, and we find the antiderivative of that. And here's our antiderivative by the substitution method. And so our final answer is 2x, 7x plus 1 to 1/2 minus what? So be careful. It's 2 times this. 2 times 2 is 4 over 21. 7x plus 1 to the 3/2. Okay, so that's how we would do it with integration by parts. Now, you might uh, say, wait a minute, let's look at that answer we got from the other method. And if we compare the two, um, they don't look exactly the same. Okay, they both have a plus C. Here's a plus C, but let's see if I can get them both on the same. Uh, so you can look, you know, they don't look the same. I mean, this is 2 over 21, 7x plus 1 to the 3/2. This is negative 4 over 21, 7x plus 1 to the 3/2. This is 2x, 7x plus 1 to the 1/2. This is negative 2/7, 7x plus 1 to the 1/2. However, these are the same, and I'm going to show you by factoring. Okay. First, the substitution method one here. I'm going to factor out the greatest common factor from these two terms. Don't worry about the plus C. We'll just leave it over there. So I'm going to factor out 2 over 21 as the numerical coefficient or numerical factor. And then I've got a 7x plus 1 to the 3/2, 7x plus 1 to the 1/2. I'll pull out the smaller power, 7x plus 1 to the 1/2. Okay. So what's left here when I pull out the 2 over 21, I'm left with 1. And then here, if I pull out 7x plus 1 to the 1/2, notice the exponent here is 3/2. So this will be left over 7x plus 1 to the first power. Because when I multiply these together, remember, what am I going to do with these exponents? I'm going to add these exponents. 1/2 plus 1 would give me back to the 3/2. Okay. Now, I factored out a 2 over 21 from 2 over 7. How can I do that? Well, it goes, there's left over 3, right? Because if I do 3 times 2 over 21, the 3, 21 is 7 times 3. The 3's cancel, and I'm left with 2 over 7, right? So 3 times 2 over 21 is 2/7. And of course, I factored out the 7x plus 1 to the 1/2. And then simplify 7x plus 1 minus 3 is 7x minus 2. So here's the factored form. And if we look at the other method, here is what we got. Here I'm going to factor out 2 over 21. Again, between 2 and 4 over 21. I'm going to factor out again 7x plus 1 to the 1/2. So here, if I factor out 2 out of 2 over 21 from 2, that leaves 21, right? 21 times 2 over 21 is 2. I still have the x left there. 7x plus 1 to the 1/2 is factored out. What about this second thing? If I factor a 2 over 21 from a 4 over 21, that leaves 2. And then again, I've got 7x plus 1 to the 3/2, pull out 7x plus 1 to the 1/2, leaves just 7x plus 1. And then just simplify what's in the brackets here. 21x minus 2 times 7 is negative 14x. 21 minus 14x, 7x. And then negative 2 times 1 is negative 2. And there's the result factored. And if you compare those two now, they are the same. So very interesting. You could do it either way. Um, Pretty interesting little problem here. Hope this helps.